let's do some counting atoms practice together, and then you're going to do some just like this on your own, so pay attention. First thing I'm going to do is obviously read the question. So our question says, how many atoms of each element are in 1 molecule of baking soda? So we want to know how many atoms of each element. So that's another way of asking for the total atoms. We want to know all the atoms in each element. Remember, step 1 is always to make your EA chart. So all right, there's my EA chart. Now I have to determine how many elements I have. I do that by looking at how many different capital letters there are. So here's 1, here's 2, here's 3, here's 4. So I have 4 different capital letters. I'm going to put them under the element side. Na, H, C, and O. Now I need to determine how many atoms of each element there are. But first, it looks like I have some 1s I need to add. Na doesn't have a subscript next to it, or a little guy. There's no little number hanging on to it, so I'm going to give it a 1. Remember, if there's no subscript, it's automatically a 1. H doesn't have a subscript, so I need to give it a 1. C doesn't have a subscript, so I need to give it a 1. And O does have a subscript. So since there is no subscript for Na, there's automatically 1 atom of Na. Same thing for hydrogen. Same thing for carbon. And oxygen has a subscript, it's 3. Remember, this is not my answer because it asks for total. So that means I need to add 1 plus 1 plus 1 plus 3. And that will give me my total. Did y'all add that? That's some tough math right there. 1 plus 1 plus 1 plus 3 is 6. And that would be our answer. Makes sense? Let's try another one. All right, this one says, how many atoms of each element are in 1 molecule of magnesium hydroxide? So I'm going to go through the same steps, but this time I see some parentheses in here. So I know this one's going to be a little more difficult, but I'm going to go through the exact same steps. I'm going to make my EA chart first. Okay, now we're going to determine how many different elements we have. So we have 1 capital letter, 2, 3. We have 3 capital letters. Mg, O, and H. Okay, now we have to determine how many atoms of each element. So let's see, do we have any 1s we need to add? Mg needs a 1, O needs a 1, H needs a 1. This 2, this little guy, the subscript 2, is outside of the parentheses. So it belongs to O and H. We have to do something fancy. Y'all done this in math class. You have to distribute. So this 2 doesn't belong to Mg because Mg is outside of the parentheses. It belongs to O and it belongs to H. So you have to distribute, or you have to multiply each of these numbers by 2. So let's go to our EA chart. And for Mg, that one's easy, it's just 1. For O, oxygen, we have to do 1 times 2 gives us 2 atoms of oxygen. 1 atom of hydrogen times 2 gives us 2 atoms of hydrogen. So remember, it wanted to know how many atoms of each element. So we still need to make sure that we find the total. So 1 plus 2 plus 2 gives us 5 total. If that question had only said how many atoms of oxygen are in a molecule of magnesium hydroxide, then we only would have need to have done this. So you have to read, is it asking for total or just one element? Let's try it a little more difficult. All right, this one wants to know the difference. Anytime you see that word, you should know you're subtracting. The difference in the number of oxygen atoms in one molecule of magnesium hydroxide and one molecule of citric acid. So they're trying to trick you because they only want to know oxygen atoms. You got to be careful. For magnesium hydroxide and citric acid. So I am going to make 2 EA charts. We need 1 EA chart for each element. But the good news is I only need to focus on oxygen. So that's the only element I'm looking at. Which means I'm going to put oxygen on each side. And then let's look. In magnesium hydroxide, oxygen doesn't have a subscript. So I need to give it a 1. But we also have this number outside of the parentheses. So I'm going to have to distribute. So 1 times 2 equals 2. So in magnesium hydroxide, there's 2 atoms of oxygen. In citric acid, oxygen has a subscript, it's 7. So there are 7 atoms of oxygen in citric acid. So this is not our answer because it asks for the difference, we're subtracting, in oxygen atoms. So difference, 7 minus 5 Oh man, I said 7 minus 5. 7 minus 2, sorry y'all. 7 minus 2 gives us 5. I'd already done the math, I was skipping ahead. So that's how we get the difference in the number of oxygen atoms. I kind of like that one because we didn't have to do the EA chart for the whole molecule. We just had to do it for that one element, only for oxygen. Let's try another one kind of like that. All right, this one says how many more chlorine atoms are represented in the formula for calcium chloride than the formula for bleach. So we want to know how many more chlorine. So we know we need to make 2 EA charts. We have 2 different formulas. But do we need to do the EA chart for every element? No, just for chlorine. Okay, so just for chlorine, I'm going to put chlorine in each of the EA charts. Chlorine is Cl. So that's a lowercase l. It goes together, Cl. And then I'm going to look. In calcium chloride, chlorine has a subscript of 2. In bleach, chlorine doesn't have a subscript, so that means it's automatically a 1. So there's 1 atom of chlorine in bleach. So it wanted to know how many more chlorine atoms. So basically that's asking us for the difference again, or how many more. Calcium chloride has 2, bleach only has 1. So calcium chloride has 1 more. And that's your final answer. So every time it's the same steps. Make your EA chart, check for how many capital letters to determine how many elements, and then add 1s and arrows to count your atoms for the right side of the EA chart.